All right, so this is the study guide that you were given today. Just want to walk through these problems with you. So hopefully this will help you be ready for the test tomorrow. Start off, all they're wanting us to do is to take and graph these parent functions. So for a linear function, you're just going to have a straight line going through the origin. That's going to have a slope of 1. So basically looks something like that. There's your linear, your absolute value. Remember, you have that V shape with a vertex at the origin. Each side would have a slope of 1 or -1 going the other direction. So that's going to give you your V. Like so. And your quadratic, that's your parabola. So that makes that U shape. So remember, the parent function for this is y equals x squared, or f of x equals x squared, however you want to look at it. It's also going to start at the origin. If you plug in a 1 and square it, you get 1. If you plug in a 2 and square it, you get 4. Go the other direction, -2, 4. And then, best you can, just sketch out that U shape. All right, and that's all they want you to do there. This is just memorization, knowing what they look like on a graph. The transformation rules, what you're doing here is just describing how each of these things affect the parent graph. So adding an h to the x, that's going to move you to the left by h. The f of x, or the f of x minus h, so subtracting h from x, that's going to move you to the right by h. Adding k, that's to the f of x, that's going to move you up by k. And subtracting k is going to move you down by whatever k is. Multiplying by a number greater than 1, or the absolute value greater than 1, that's going to be a vertical stretch. Multiplying by a, absolute value of a less than 1, remember that's the same as saying between 0 and 1, so a fraction less than 1 but greater than 0, that is a vertical compression. And the negative x, or negative f of x, so the negatives in front, that's a reflection over the x-axis. All right, if you need to review any of this, look at that purple sheet that I gave you in class. All right, the vertex form of an absolute value function, well, the vertex form is just f of x equals a absolute value x minus h plus k. Applying that, what you can pull from vertex form is you can pull what the vertex is and basically the slope of the sides. So this is your h and this is your k. You relate that back to the x and the y. So for the vertex for this point is going to be 2, -7. Remember, the x value, your h is opposite when you pull it out. So this graph is going to start at +2, -7. So right there. All right, to get the slope, you look at the a, and in this case, it's an understood 1. So that means up 1 over 1, up 1 over 1 from the vertex. And then the same, just going the other direction to the left. All right, take and graph line. Your domain is basically how far left and how far right. For an absolute value function, your domain is always all real numbers. Your range is how far up and how far down. The lowest this graph will ever go is -7. Since it's included, you'd have a bracket, and then it continues on to positive infinity. All right, for the next problem, your vertex is going to be at 0, 4. Since there is no h, your h is 0. All right, so we plot that right there. Your slope is a -2, so down 2 to the right 1, and down 2 to the left 1. Down to right, down to left. Make your graph. All right, the domain, again, how far left and right, it keeps moving left and right, so your domain is all real numbers. Your range, the lowest it goes, well, it keeps going down, so that goes to negative infinity. Coming the other direction, the highest it's ever going to go is positive 4. So there's your range. All right, number 3, they're telling us that the parent function of an absolute value equation, so my parent is f of x equals the absolute value of x. So for both of these, we're going to be using the same parent function, and they're asking me to write the transformed function, so using these descriptions. So I'm just going to jot those again. So reflected across the x-axis, and then we shifted 5 left, so left 5. So I want to do this step by step. I think you're less likely to make a mistake. So taking the parent, showing that it's reflecting across the x-axis, I need to put a negative in front. So that would give me the negative of the absolute value of x. Now take this and show that we move to the left 5. So that's going to be a plus 5 inside. And so we get the final answer, g of x. Since I've already used f of x, I need a different letter. So g of x equals negative absolute value x plus 5. And that's the answer for that. All right, for number 4, again, step out. We're going to have a vertical compression by a factor of 1/3. And we're going to shift up 1. And we are going to go to right. All right, so again, the parent function, f of x equals absolute value x. We're going to take that, and that's going to become a 1/3 absolute value x. Add the 1, have a 1/3 absolute value x plus 1 on the outside. Moving it right to, it's going to be an x minus 2 plus 1. So we get the final answer, g of x equals 1/3 x minus 2 plus 1. All right, number 5, we are graphing the inequality. So I'm going to identify my vertex, which for this problem is -6, -4. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. The slope would be 1, so up 1 over 1, up 1 over 1, take it the other direction. Here we got to pay attention, since it's just a less than, you got to use a dashed line for your sides. Same with the other way, dashed lines. And we also have to do shading, so less than means we're going to shade underneath. So here is number 5. Number 6, your vertex is at -3, 0. Slope is a -2. So down 2 over 1, down 2 over 1. This will have a solid line because of the greater than or equal to. And since it is greater than, I would be shading above. All right. Next one, number jump to 20. So here we're just graphing the piecewise function. I'm just going to do this using the table like we discussed. So I'm going to take that first piece, come up with a table. So first x is where it ends, and then any numbers less than that. So -5, -6. Plug in a -4. That's going to take us down. Let's see, -4 times 2, that's -8, plus 1 is going to give me a -1. Plug in a -5 times 2, that's -10, plus 7 is a -3. Plug in a -6 times 2, that's -12, plus 7, that's a -5. So if I plot that, -4, -1, paying attention to the inequality, since there is no equal to, we'll have an open circle. And then -5, -3, and then -6, -5. So that takes care of that piece. Now for the -1 over 4, x, again, going to make another table. Still testing at -4. Since I have to multiply by a 1/4, I'm going to pick numbers that are divisible by 4. So getting numbers bigger than -4, we could use 0, and I could use +4. Plug in a -4 times -1/4, you're going to get a +1. Plug in a 0, you're going to get 0. Plug in a 4, you're going to get -1. All right, plotting these points, -4, +1. Since it's a or equal to, you'll have a closed circle. Have a point at 0, 0, and have a point at 4, -1. So just connect that. There's your other piece. The domain of this function, looking left and right. So as I go to the left, it keeps moving left. As I move to the right, the graph's going to keep moving to the right. So my domain is all real numbers. Our range, as I go down, so this is going to keep on going to -infinity. As I come back up the other direction, there is a possibility of there being a problem because of this gap, but this gap is filled in by this piece of the line. So that's not a problem, but the highest on the y-axis this ever goes is +1. So it's going to stop at +1, included because of the closed circle. All right, 21. With this absolute value, I'm going to take note of where the vertex is. So since this is an absolute value function, you look at the h and the k. So this has a vertex at -2, 0. So that when I make my table, I'm going to make sure I account for the vertex. So I still want to know what happens at 1. I want to include -2 since it is less than 1. That's okay. And then I want something past -2 so that I make sure I get a point on each side of the vertex. So -3 will be fine. All right, so plug in a 1, 1 plus 2, that's 3. The absolute value of 3 is 3, but then it goes to be a -3 with that negative on the outside. At -2, I know the y value is going to be 0. At -3 plus 2 is -1. Take the absolute value, that's 1. Goes back to being negative, so -1. So at 1, -3, I would have an open circle. 2, 0, that's the vertex. -3, -1. That's going to give me that V shape going back down. All right, for the second piece, 3x minus 5. Again, I want to know what happens when x is 1, and now I need numbers that are bigger than 1. So 2, 3. So plug in a 1, 3 times 1 is 3, take away 5, -2. Plug in a 2, 2 times 3 is 6, take away 5 is 1. Plug in a 3, that's going to give you 9 minus 5, which is 4. So +1, -2 would have an open circle. 2, 1, 3, 4. All right, connect those. So there is your piecewise function graph. Looking at the domain, the x's and the y's left and right. So as I go to the left, this is going to keep on going to the left. So I'm going towards -infinity. Coming back the other direction as I move across. So keep moving right, I'm okay. Moving right, I'm okay. And then here's a problem. That being an open circle means when x is 1, I do not have a point on the graph. And if I look at the next piece, I also do not have a point on the graph. So when x is 1, there is not a point on my graph. So we go up to 1, but we don't include 1. So we get parentheses. But once I get past 1, then I get back on the graph and there are no more problems. So union, pick back up at 1, go past 1, and then going towards +infinity. So that would be my domain. For my range, as I'm moving down, this piece keeps going down, so towards -infinity. As I'm coming back up, so as I'm going up, I'm moving along the graphs. This starts going back down, but that's not a problem. Could have an issue right here between these 2 points, but this piece of the graph is going to take care of those y values. So all real numbers, because this is going to keep going up to +infinity, that's going to keep going down to -infinity. And any gaps I have, that's kind of filled in with the other pieces of the graph. All right, number 22. So as long as x is less than or equal to 0, y is always 5. So that's just a horizontal line through the y-axis at 5. So I have an open circle, excuse me, closed circle, and then a horizontal line going to the left. For this, I would make a table. So I want to know what happens at 0, and I need numbers bigger than 0. So 1, 2. All right, so plug in a 0, square it, you get 0, -0, still 0, 0 plus 3, 3. So plug in a 0, we get back a 3. Plug in a 1, you're going to get back a 2. Plug in a 2, you should get back a -1. So I plot those points, 0, 3, which would be an open circle. 1, 2, 2, -2. You should recognize this is a quadratic, so it's going to have that parabola shape. And so as we see, since I'm going down, it's going to have a curve downward. All right, domain, left and right. So towards the left, we keep going, so that's not a problem. So I am approaching -infinity. Coming back the other direction, could have an issue here with that open circle, but that open circle is basically taken care of with that closed circle. So that when x is 0, I do have a point on my graph. So that's not a problem. And as I keep moving to the right, this will go down sharply, but it's also slowly moving to the right. So it's going to keep going towards infinity. So -infinity to infinity, or we could just say all real numbers. For my range, going down, since this keeps going down to -infinity, I'm going to be going to -infinity. Coming back up, I run into a problem right here because from here to here, there are no y values on my graph. So coming up, I'm fine until I get to +3. Once I get past 3, so 4, there's nothing, but I pick back up here at 5, but it never goes above 5. So union y equals 5 would be my range. All right, last one, number 23. So here I got 3 pieces, so we'll just be using 3 charts. Take the first one. So I want to test at -2. This is when x is less than -2, so -3, -4. Plug those in, you're going to get -7, -6, -5. For the next one, I want to test at the boundary, so -2 stops at 2, and something in between, we're just going to go with -1. All right, plug in a -2, you're going to get 4. Plug in a -1, you should get -4. Plug in a 2, you should get 4. And for the third piece, keeping in mind the vertex here is at 3, 0. My equation, make a table. I want to know what happens at 2. Pick a number bigger than 2. 3 is going to look good. And then we'll just go with 4 to get the other side of the vertex. So plug in a 2, we should get back a 2. Plug in a 3, you're going to get 0. Plug in a 4, you're going to get 2. All right, so plotting these points, -2, -7. I'm going to put me right here, open circle. -3, -6, -4, -5. So this is just going to keep going up. Slope of 1. All right, quadratic, that's a parabola, so you're going to have that U shape. It starts at -2, and then 2, 4. This should be -4. If I messed that up, yeah, that should be -4. Go back and fix that. Plug in a -2, square it. No, -2 plus 1. That's -1, square it. No, yeah, no, that should be -4. Messed up on my point there. So -2, -4, we would have a closed circle because of that inequality. We have the point -1, -4. That's not right either. That's -5. I'm messing that up. That should be -5, not -4. So we would have the point -1, -5. And then we're going to have the point 2, 4. So we're going to get a really sharp curve here. At that point, we should have an open circle. So make it have that parabola shape. And then here we got the absolute value, so I know I'm going to have that V shape, and it starts at 2, 2. Crap, I messed that up too. I'm just messing this all up. All right, let's fix this. All right, 2, 4, 1, 2, 1, 2, 3, 4, just right there. There we go. All right. Plotting this 2, 2, closed circle, 3, 0, 4, 2. All right, domain left and right, to the left, so to -infinity. Coming back the other direction, this could be a problem with that open circles taken care of with that closed one. So we're fine, we're fine, we're fine. Open circle here, so it could be a problem, but that's fixed by that closed circle there, and it just keeps going to the right. So negative infinity to positive infinity, or just say all real numbers. Your range up and down. So the lowest it's ever going to go is at -7 parentheses, because it's an open circle. Keep moving up, so that's fine, that's fine, that's fine, that's fine, that's fine. Where I run into a problem here, no, because this gap is fixed by that piece of the graph, so that's just going to keep on going to positive infinity. All right. Any questions you have, make sure you have those ready to ask me before you step into class tomorrow. Study, study, study.